Okay, changing forms notes. So first of all, we should be very familiar with solving this type of equation here. Notice you can easily change the 9 to base 3. So solving this, we get 3 to the x equals 3 squared. And basically, canceling out the 3's, we get x equals 2. Very simple. But what happens when we can't make the bases the same? Well, then we're kind of stuck. So we're going to have to learn a new way of solving exponentials when the bases cannot be made the same. So we'll come back to that problem. Here are some examples of exponential equations that have been transformed to logarithmic equations. So it says, can you find the pattern? So take a moment and look at these examples and see if you can see how they were changed. Okay, let's take a look at the first one. Notice that the base of the exponential, the 3, became the base, the little number on the log. The base of the exponential became the base of the log. The exponent on the exponential function became the answer of the logarithm. And then the answer of the exponential became the argument of the logarithm. And that's how we rewrite an exponential function as a logarithmic function. That's where we put the numbers. These are the same, just written differently. So let's look at the first one. So 5, that's the base. So we're going to start by writing log. So where does the number go? Correct. Down below. The exponent becomes the answer. And I forgot a little space here. And the 125 is the argument. Ran out of space here. Let me rewrite that. Log base 5 of 125 equals 3. Log base 5 of 125 equals 3. Okay, let's go backwards. So starting with the base, always start with the base. So the 3 becomes the base. The 2 is the exponent. And 9 is the answer. So you kind of go around in a circle. You start with the base, raised to the exponent equals the answer. Okay, so you do this one for me for tomorrow. Okay, evaluating. How do we solve this? So first thing we want to do is we want to rewrite it as an exponential function. So we're going to take the base, raised to the exponent. Well, we don't know what the answer is, so we're going to use an x. 3 to the x equals 243. Okay, so solving this, you could do a guess and check, or you can change the base to base 3. So 3 to what power is 243? Someone in the class right now want to tell me what that is? 3 to what power is 243? Thank you. So making the bases the same. So canceling out the 3's, x equals 5. Thank you, Ian, for the help. Ian. Okay, which value is equivalent to log base 10 of 1,000? So again, we're trying to figure out is 10 to what power is 1,000? So converting it to exponential, 10 to what power is 1,000? So we're going to have 10 to the x equals 10 to the third power. Canceling out our 10s, x equals 3. Okay, let's take a look at this one. We have log base 8 of n equals 4/3. So we rewrite it using exponential. So we're going to have 8 is our base, raised to the 4/3 equals our argument, which is n. So we don't need a calculator for this. The cube root of 8 is 2. 2 times 2 times 2. And 2 to the 4th power is, well, 16. So n is 16. To solve a logarithm, you need to write it as an exponential function and then solve that equation. Okay, so why don't you try this one for me for tomorrow, and I will check these two answers tomorrow.